In this video, we are looking at some of those questions for our review that we are doing for our quiz on Friday. So I'm just going to go through each of these questions so that you can see how I would go about solving them. Doesn't mean this is the only way to solve it, but this is one way to get to that answer. So let's just go ahead with this first one about kind of our scale. So the scale on a map is 1 inch to 8 miles. Two towns are 2 3/4 inches apart. How many miles apart are they really? So I would first go ahead and make a box here to do kind of a small ratio table. So we have our ratio and we have our actual count. Now what we are doing here is making sure that we have our ratio based on this scale. So our ratio in inches, and this is of course our drawing, is 1 inch to 8, and this is miles in the real life. So if we have 2 3/4 inches, how many miles are they? Well, we could make a ratio or a proportion here if you would like. 1 over 8 equals 2 3/4 over x, or you can see that there's a scale factor from 1 to 2 3/4 of 2 3/4, so I need to multiply 8 times 2 3/4. Well, when you do that, I would put it as an improper fraction first. So this would be 8 times, well, 4 times 2 is 8 plus 3 is 11 over 4. I can do a little bit of reducing before I do anything else. Looks like I'm just multiplying 2 by 11 and get 22 miles. And that is our answer. It's 22 miles apart. All right, the next one says triangles XYZ and RYT are similar. Segment XY is 35 centimeters. Find RY. Well, we have this funky figure. I'm actually going to draw it as two different triangles so that I can see my similar triangles. This one is RTY, doing the big outside triangle. And then I have a small inside triangle that's XZY. Well, we have some information. This is 70 and this is 80. And then I also know from the description that XY is 35. So I could set up a proportion here to talk about the corresponding sides. So that side that's 70 corresponds to the side that's 80. So 70 over 80 equals, well, if I want RY, I want to know that 35 relates to X somehow. Well, there's a lot of ways to do this. I would actually look at this and say 70 divided by 2 equals 35. So 80 divided by 2 is 40 centimeters. And that's our answer. So I would set up that proportion, but then find a scale factor. All right, moving right along. So a $15 item is on sale for $12. By what percent is the item marked down? Well, we have a lot of different ways that we could look at this with a ratio box, but I'm actually going to go with that formula that we learned a little while back that talks about the change divided by the original. So when I look at these, if my item was originally $15, that's going to go on the denominator. And the change that I have here from $15 to $12 is a change of $3. Well, then to turn this into a percent, I'm going to always multiply by 100 to get it as a percent. So I look at this and say 3 over 15 is 1/5 times 100. Well, 1/5 as a decimal is 0.2 times 100 must be 20% discount. Okay. The height of the cone is 21 centimeters. Find the volume. Well, volume of a cone or of a pyramid is 1/3 of the area of the base times the height. So when I plug in these measures, I'm going to do 1/3 times the area of the base, which the area of the base is a circle. So I'm going to do pi times my radius squared. And then my height, it says in the description, is 21. So when I multiply all these together, I get 1/3 times 3.14 times 100 is 314 times 21. When you work all that out, and take some time to do that, of course, you should have done it already, but you get 2,198 centimeters cubed. All right, Same cone or similar shape here. We have a cone again, but this one has a diameter of 4, a height of 6. So what is the slant height of this cone? Well, remember that slant height comes from taking a, basically we're dissecting this cone and we have a cross section of it that is a triangle. If I were to take a cross section of this right here, it would just be a triangle. So I can describe this having a base of 4 and a height here of 6. Well, in order to do this, I can take just part of this. So I'll outline it. I'll make this a little smaller. This might help. I'll outline it in red here. Okay, here's my right triangle. And so when I draw this right triangle, I have a height of 6, a base of half of that diameter, so 2, and I can use the Pythagorean theorem now to solve this. So 2 squared plus 6 squared equals c squared, my slant height. So I get 4 plus 36 equals c squared. So 40 equals c squared, which I'm going to take the square root of each side, and then I'm going to simplify that square root of 40. Well, do your prime factorization or your perfect squares. Regardless, you're going to get 2 root 10, and we are in centimeters. Okay, so let's continue on. Evaluate the square root of x squared plus 3ab. When x is 5, a is -2, and b is -4. Well, all this is asking you to do is plug in the numbers like you see in the square root. So I'm going to do 5 squared, that's x squared, plus 3 times a, which is -2, times b, which is -4. And then all I have to do here is follow PEMDAS to solve. So I'm going to square this and get 25 plus, and then we do multiplication, 3 times -2 times -8. Well, that's going to be a positive 24. And then I'm still not going to square root anything yet because I'm still inside of the square root. I'm going to add those up, get square root of 49, which just has one answer of 7. All right. The dimensions of a prism are tripled. The volume of the enlarged prism is how many times the volume of the original? Well, what it's telling us is if we have a prism that's been tripled, my perimeter scale factor is 3. Because if my cube was 1 by 1 by 1, let me draw this as a cube, then my new one is triple that, so I have this much bigger cube. That is 3 times that, 3 by 3 by 3. It's tripled. So my area scale factor, based on our information that we've learned before, I'm going to square 3 and get 9. And my volume scale factor is 3 cubed, or 27. So I would say it's 27 times bigger in the volume. Okay, so write an expression for the perimeter of the rectangle. Well, it gives me dimensions that have variables in it. So I'm going to have to add up all of these sides, but since this is a rectangle, I know that this is x minus 1 over here as well, and this is 4x plus 2, same as that top. So I'm going to add up 4x plus 2 plus x minus 1 plus 4x plus 2 plus x minus 1. I'm just adding up all of those sides. And I can combine like terms, 4x and x, 4x and x. Well, when I add all of those up, I get 10 x's. And then I can add up the numbers, 2 and -1, 2 and -1. Well, then of course we just get plus 2. And that is the perimeter of my rectangle. Same rectangle here, but now we want to find the area. This is when you would use something like FOIL or an area model or rainbows and smiley faces. Regardless of what you do, we need to get the area of this. I will show the rectangle. So I would label this with 4x and 2, just the dimensions of that top, and x minus 1. Then I just have to find the area of each of these smaller squares. So 4x times x is 4x squared. 2 times x is 2x. 4x times -1 is -4x. And 2 times -1 is -2. And then I can add all of these pieces up, but some of them are like terms. 4x squared is not a like term, and negative 2 is not a like term with anything, but this 2x and negative 4x, those are like terms. So I can combine them and get negative 2x, and that's my area. Regardless of what method you use, you should come out with that area. All right, which of the following is a subset of rational numbers? Well, rational numbers include a lot of different things. And when we consider our rational numbers, the only thing that really matters is that we can show it as a fraction. So which of these 4 options shows numbers as fractions? Well, imaginary numbers, we haven't really talked about those, but those definitely are not rational numbers. Irrational numbers, just by the name of it, of course, they are not rational numbers. Real numbers actually includes both rational and irrational numbers, so those are actually out. The only one that is a subset of the rational numbers is whole numbers. My whole numbers are a subset of my rational numbers because all of my whole numbers can be shown as a fraction. Okay. Next, we have an inequality that we are asked to graph it on a number line. So I start this number line and I see that my x is by itself, so I'm good to go as far as graphing this. But I need my graph from negative 4 to 3, add a couple numbers in between, and then we can say based on these inequality symbols, we know what type of dots to put on here. So with that less than symbol, I need an open dot on the negative 4. With the closed on the 3 because of that less than or equal to sign. And then since this is a compound inequality, an and situation, we're going to put a line in between these. And you can check this if you would like. You can split this into 2 different inequalities. Negative 4 is less than x, and also x is less than or equal to 3. Regardless, you're going to get this inequality graphed. Okay. Next we're going to solve, but this is a quadratic, something that has an exponent of 2, but we're going to solve it very similar to what we would do with regular linear functions. We need to get rid of that plus 7 first by subtracting. We get 2x squared is equal to 18. We divide by 2 and get x squared is equal to 9. And then since we need to get rid of that squared, the opposite of that is square rooting. So when I square root each side, I get x could be, now we have to remember, we have 2 possibilities here since this is an equation. We have plus or minus 3. Okay, graph the equations to find one pair of x and y values that is the solution to both equations. So if I graph these, they're both in slope-intercept form. And so I can use the slope and y-intercept of each in order to graph them. Hopefully you use graph paper for this. For the first one, we have a y-intercept of 1 and a slope of 1, so I'm going to go up 1 over 1 all the way across. And then when we do our next one, negative 2x plus 7, I have a y-intercept of up 7 and then a slope of negative 2. So down 2 and over 1, down 2 and over 1. When you do this, and if you do it on graph paper, the intersection point should be pretty clear. When you do this, it is actually at 2, 3. And I could check that. If I plug it into both of those equations, we will get true statements. All right, Sunny's camel runs 5,000 meters in 5 minutes. Convert this to kilometers per hour. So I have this rate of 5,000 meters to 5 minutes. Well, I need to use 2 unit multipliers to convert this. I'll do the minutes first. So I can say to hours, if I put my minutes on the top, it'll cancel out, and I'm changing it to hours. So 60 minutes is 1 hour. Minutes go away. And then those kilometers. So my meters is on the numerator, so I need to put the meters on the denominator to convert it to kilometers. And 1 kilometer is 1,000 meters. And now my meters have gone away. So now I can simplify and solve. Yes, you can go ahead and multiply it first, or in this form you can go ahead and simplify. I will simplify first. And I see this 1,000 with this 5,000 can cancel out quite a bit. Well, now I have a 5 and a 5 that can cancel, and I am just left with 60 kilometers per hour. All right, now some dice, some probability. 3 dice are rolled at the same time. What is the probability of getting 2s on all 3 dice? So we're looking at some independent events here. They're not going to affect each other, but I need to find the probability of each one of these events. So for the first die, the probability of getting a 2 on that, well, 6 possibilities, only one of them is a 2, so the first probability is 1/6. On the second die, it's the same, 1/6, and on the third, it's also 1/6. And to get all of these to happen at the same time, we would multiply across, and I would get 1 over 6 cubed, or 216. That's the probability of getting all 2s on those 3 dice. All right, how much money is 8 1/3% of $96? Now, 8 1/3% is not one that we commonly use, but we can definitely turn it into something that's a little bit easier to work with. I'm not going to turn it to a decimal because I would get 8.3 repeating percent, or 0.083 repeating. I don't want to work with a repeating decimal, so let's turn it into a fraction. And how we do that is turning this percentage into an improper fraction. So we get 25/3%. And then in order to turn something into, basically take it out of a percent and turn it into a fraction, I need to divide by, I need to take this, I was right, divide by 100. There we go. Divide by 100. Now when we do that, if I'm dividing some fractions, I need to multiply by the reciprocal. So I'm actually taking 25/3 times 1/100. When we simplify, I realize that 8 1/3% is 1/12. I want 1/12 of $96. Well, that's not too difficult, and when you do take 96 and divide by 12, I get $8. So turn that repeating percent into a fraction, and it'll make it quite a bit easier. Okay, solving for x in this equation, I am going to expand first and get 5x minus 10 plus 3x equals 30. I need to combine like terms here, and I get 8x minus 10 equals 30. To get rid of that subtraction, I'm going to add 10 to each side and get 8x equals 40. So divide by 8x equals 5. All right. Now we have some fractions that we have to deal with when we are solving for x. But same rules apply. I need to get rid of this 4/5 first because it comes first in PEMDAS backwards. So it's a positive 4/5, so I subtract it from each side to get rid of it. And I get negative 3/5 x equals a negative 1/5. And then to get rid of this negative 3/5, I'm going to divide by negative 3/5 on each side. Well, when we divide fractions, I am actually going to multiply by the reciprocal. So negative 1/5 times negative 5/3. It gives me a positive 1/3 as my x. And that's my answer. Simplify. Well, we could go ahead and multiply these two radicals together. It's going to give us a big number that we're then going to have to break down into different pieces. I would actually rather figure out the pieces of each of these first and then multiply them. For example, the square root of 14 would actually be square root of 2 times 7, and the square root of 18 would be 2 times 3 times 3. Then I can combine these into one big radical to get 2 times 2 times 3 times 3 times 7. I put them in order like this because then I can look at the pairs that I have. I have a pair of 2's that I'll circle and pop, a pair of 3's that I'll circle and pop, so that I have a 2 on the outside, a 3 on the outside, and a 7 left in my radical. I simplified just a little bit to get 6 root 7, and that is my simplified version of these radicals. All right, what is the sale price of a video game if the original price is $58 and there is a 30% discount? Well, I'll just talk through a little bit of what you would do and then what the answer is. So if the original price is $58 and there's a 30% discount, you can go about it two ways. You can figure out if I find 30% of that, then I can take it away from 58. So 58 minus whatever you get here. Or you can say if there's a 30% discount, I must be paying only 70% of the price, and that will be my answer. Regardless of how you go about it, you will get $40.60 at the end. Okay, just a couple more here and then this video will be finished up. So last year, a shed in Sally's backyard had a perimeter of 30 feet and an area of 50 feet squared. This year, she needs more space and wants a perimeter of 90 feet. What is the area of the new shed? Okay, so there's a couple different ways that you can go about this. What I would do is use perimeter scale factors. If I am saying that she had a perimeter before of 30 feet and now it's 90 feet, well, then I must have tripled the perimeter. If my perimeter scale factor is 3, then my area scale factor must be 9. So that I can take that area of 50 feet squared, multiply it by 9 to get my new area of 450 feet squared. That's what I would do. Using those scale factors, it actually makes the problem quite simple. If a plane trip takes 2.5 hours to go 500 miles, how long will a trip take if we need to go 950 miles? Well, this is really just assuming some proportions. We can say something like this. If I have 2.5 hours relates to 500 miles, then how many hours, X hours, for 950 miles? In this case, I don't see a really clear scale factor. That's super easy to use, so I would go ahead and cross multiply to get 500x is equal to 2.5 times 950, and then you would multiply that out and divide by 500 on each side. Regardless of how you go about it, whether it's with that proportion or maybe with a scale factor, you would get 4 3/4 hours. All right, so practicing slant height one more time. If the diameter of a cone is 8 inches and the height is 10 inches, what is the slant height of the cone? With the same process that we did above, we're going to get a triangle as our cross section that has a height of 10, a base of 8, that we can then use the right triangle that's part of this to find the slant height. But that triangle is going to have a height of 10 and a base of 4 to put into the Pythagorean theorem. 4 squared plus 10 squared equals c squared. So 16 plus 100 equals c squared. And then we're going to square root. Well, the square root of 116 is not quite simplified. There is actually 4 times 29 gives us 116. So we simplify that to 2 root 29 inches. That's our slant height of that cone. All right, and then one last problem here, the volume of a cone. We have a diameter of 10 and a height of 9. What's the volume? Well, volume is 1/3 area of the base times the height. So 1/3 area of that base. So pi, or actually in this case it wants it in terms of pi. So we'll leave pi as pi times radius squared and then times our height of 9. That gives me 1/3 times pi times 25 times 9. Actually, see this 1/3 times 9 will work out quite nicely. If I do 1/3 of 9 is 3. So I'm really doing volume is 3 times 25, 75 pi inches cubed. All right, and that was our last question of this review. I hope this helps you as you study for your quiz on Friday.